All right. Today we're going to be working on translating equations and inequalities. So we're taking words and we're changing them into math. So hopefully we can take this problem and create an equation or an inequality out of it. And in order to do that, you're going to need to know what are like the main words that mean, the operations of math, like to add, subtract, multiply, divide, so forth and so on. So if you want to pause it, that's fine. I want you to think about what are some words you know that mean to add, subtract, multiply, and divide. And this should kind of be a little bit of a review for you. So some words that I thought of that represent addition. Whoops, that's not what I want to do. Addition. Some words that I found were sum is a big word. Sum means the answer to an addition problem. Also more than. Anytime you see more than. Increased by. Add, obviously, and plus. It's like the most basic one. So those are all addition words. Subtraction. Subtraction, obviously, is subtraction. There's also difference. Difference means to subtract. Minus, that's a pretty basic one. Decreased by is a better one. And then one that I want you to star or circle or put a heart around is less than. And then what I also want you to do is I want you to do this. I want you to draw that. Whenever you see less than, you have to reverse the order. So for instance, if I said x less than 4, most people want to say that that's x minus 4. It's actually 4 minus x. Anytime you see less than, you just switch those two numbers around. Okay. Continuing on, we have multiplication. Obviously, multiply. A basic word is times. You've heard that before. Product is a better word. That means an answer to a multiplication problem. Of is a big one. And, when they say twice, that basically just means multiply it by 2. Division. Division, we have divided by. We have quotient. That's a good word. That means the answer to a division problem. Half. Anytime you see half, that just means divided by 2. Another good word is ratio. Anytime you see ratio, that means you're going to do a division. And it goes in the order. So if I say the ratio of boys to girls, so the boys to girls is 3 to 4. That means you could write it as 3 divided by 4. Okay, so some words you might not be super familiar with. Since we're doing equations, remember have equal signs. Inequalities means that there's more than one answer, and that's when you have either the less than or the greater than or the less than or equal to or the greater than equal to sign. So the one that looks like an L, this to me looks like a slanted L, that's the less than sign. And some words that represent less than, and I personally get kind of confused with these, so it's important you write these down. If you see fewer than or smaller than, that means less than, the less than symbol. Similarly, for the less than or equal to, so that means it can equal that number, but it could also be smaller. You have some words that represent that are at most, a maximum of, or no more than. And how I kind of have to, like, when I get confused and if I don't have this committed to memory, I think of this as spending money. Because you can ask anybody in my family, I'm a little frugal and I don't like to waste my money. So when I'm like going out shopping, let's say I don't want to spend, like, let's say I have like $100 or something. I don't know. Let's say I only have 20 bucks. I don't know. And I cannot spend that $20. I do not want to spend that $20. I want to have at least $1 left over. So I need to spend no fewer than $100, or I need to spend smaller than $20, excuse me. And similarly, let's say I wanted to spend my entire 20 bucks. I could spend at most 20 bucks. That means I could spend the 20 bucks, or I could spend a maximum of 20 bucks. I could spend 19 bucks, I could spend 18 bucks, but I could also spend the 20 bucks. Or another way to say it is I could spend no more than 20 bucks. Again, I can spend less than 20 bucks, but I can also spend that 20 bucks. Similarly, for the greater than symbols, some words that mean greater than are larger than, or more than. So something I like to think of when in terms of like the greater than is when I'm asking for money. Yeah. Well, I don't get a chance to ask for money very often. But let's say I'm going to the bank and I need, I need 2 grand to help fix my car or something. So I need more than $2,000 to fix my car, right? I'll need $2,000 for my car, and then I'll probably need, a couple bucks to help me out with a rental car. Or I need larger than 2 grand is what I'm going to ask the bank. I need more than 2 grand. Let's say I just need 2 grand. I could get by with 2 grand. I can take the bus or walk or something. I could say I need at least 2 grand. That means I'd be okay with 2 grand, but I'd really like more. I'd need no fewer than 2 grand. So I need at least 2 grand or more. Or I can say I need a minimum of 2 grand. Cool. Okay, so those are some words. CP, you can stop it. HP, we're going to move on. HP, we're going to also talk about interval notation. So we're going to be looking at inequalities again today, like I said. And I want to show you just a different way of writing them. And that different way of writing it is in interval notation. So other than using the greater than or less than sign, we can use interval notation. And you use this in other classes like your pre-calc and your calculus classes. So for instance, let's say I gave you the inequality x is less than 3. X is less than 3. So that means I wanted to graph it at 3, I would have to put a circle at because it can't be 3, but it can be anything over here. It could be 0, it could be negative 100, right? In interval notation, rather than using the symbols, excuse me, we can use parentheses to exclude the endpoints. So for instance, since 3 is not a value that fits the solution, I put 3 here and I put the parentheses. However, does this graph ever end? No, it goes on forever and ever and ever in negative infinity. So how I read this is the solutions that fit go from negative infinity all the way until 3, but it doesn't hit either of those. So it doesn't hit 3. And to think about it, you can't ever hit negative infinity because negative infinity doesn't exist, right? It never ends, so there's no hitting it, which is why we use the parentheses. If you do want to include an endpoint, you put the brackets. So for instance, in the next example, if I want to say x is greater than negative 2, I would put a closed circle, and then I'd go all the way over in this direction, and that means my x could be 0, again, it could be 100, and to do this, again, you read it left to right, I want to include negative 2, so it starts at negative 2, and then goes all the way to infinity. But can it ever hit infinity? No, so that's why I'm going to put a parentheses. So all the solutions include negative 2, and they go all the way towards positive infinity. So similarly here, if you want to pause it and try it, you're more than welcome to. I'm going to do the graph for you. So this one, it goes from 2 to 4, and it does not include either of those. So I'm going to do open circles, and so it includes all of these values. In interval notation, since it doesn't hit 2, I'd use the parentheses. And it starts at 2 and it goes all the way to 4. So we read it left to right just like we do in English. And again, 4, it doesn't hit, it's not a solution. So we're going to put the parentheses. Oops, this one cut off. Let's make this 3. Okay, so the last one, 1 is a solution and 3 is a solution, and all the numbers in between are a solution. So I would say it starts at 1 and it goes all the way to 3, and everything in between those two numbers are solutions. So this is just another way of writing something you've already learned before, and this is called interval notation.